Today we're going to review the slope formula and some relationships with linear equations. So we'll start right off with the slope formula. Slope is described as a lowercase m, and it's always the change in y, so y2 minus y1 over the change in x, x2 minus x1. So if you have two coordinate points, you can calculate the slope of the line that would pass between them. For example, if I have the point -2, -3, and -5, 7, what I usually start off doing is labeling x1, y1, x2, y2, and the slope of that line is going to be y2 minus a -3, which is y1, over x2, which is -5, minus a -2. So here's the important thing. If you start with y2, which is here, you have to start with x2, which is here. You have to go in the same order. So when I do that, I have 7 minus a -3 turns into 7 plus 3. -5 minus a -2 turns into -5 plus 2. And we end up with 10 over -5 plus 2 is -3. 10 over -3. So that is an overall slope that is negative. We could also represent it as negative 10 over 3, where the negative's in front, or if you had reversed the order, you would have come up with -10 over +3. All three of those values represent the same quantity. So we have different types of slope that we talk about. A positive slope is obtained when you calculate the slope and you have a positive over positive or a negative over a negative. Both of those turn into a positive slope. And a positive slope would increase as you move left to right. Moving left to right, my slope is increasing. An example of an equation with a positive slope, y equals positive 1/2 x plus 3. Remember, the slope is the coefficient in front of the x, so as long as that's positive, my line would be increasing up 1 to the right 2, up 1 to the right 2. A negative slope would have one of those values as negative. So a negative slope decreases as you move left to right. So as I'm moving this way, my slope is decreasing. An example of that, y is equal to -2x plus 5. Again, in this case, my y-intercept is still positive, that doesn't matter, but my slope is negative, which means I would go down 2 to the right 1, down 2 to the right 1, and decrease. Now, zero slope is what happens when I have a 0 in the denominator. So 0 over any number is going to result in a 0 slope, and that's a horizontal line. An example of that is any y equals equation. So let's say y equals -2. X can be anything you want. Y is always going to be -2, and that's going to result in a horizontal line. Finally, undefined slope is any value over 0, because we don't like to represent fractions with a 0 in the denominator, so we call it undefined. An undefined slope is a vertical line. It's an x equals equation, so let's say x equals 7, and we say undefined, or we also say it has no slope. So those are our 4 different types of slope. Another property of slopes and lines are whether they are parallel or perpendicular. Those are special cases. Parallel lines, in two-dimensional geometry, they never intersect, and so therefore they have the same slope. So examples would be y is equal to 2/3 x plus 7, and y is equal to 2/3 x minus 4. In both cases, the slope is 2 over 3, So if you were to graph them, they would be parallel on your graph. Now the second type would be perpendicular lines. We know from the rest of our geometry that perpendicular lines cross at a right angle, and they have a special relationship between their slopes. They have slopes that are negative reciprocals. Have slopes that are negative reciprocals. Okay, so for an example, if y is equal to 1/3 x, the slope of that line is 1/3, and the slope of a perpendicular line would be -3x, and then some other y-intercept. So the slope of the perpendicular line would be a negative reciprocal. If I start with 1/3, the perpendicular slope is -3, or -3/1. You flip and you change the sign. So we're going to work through a couple of examples demonstrating how you would use this information in a typical problem. So our problem here says write the equation of the line parallel to 2x plus 3y is equal to 9, passing through 6, 2. So what I need to do is I need to write the equation of the line. Some important information is the fact that these lines are going to be parallel, and it's going to be parallel to this given line, but it's going to pass through a new point, 6, 2. Well, the first thing I do is look at my line equation, and you can see here it is not in point slope or y-intercept form. So we want to solve for y. Once we solve for y, we're going to steal the slope, and then we're going to write the new equation. So that's what we're going to do. To solve for y, we've got 2x plus 3y is equal to 9. Subtract the 2x. 3y is equal to -2x plus 9. Dividing by 3, I end up with -2/3 x plus 3. Here's what I do. If I want a parallel line, that means I'm going to steal the slope and use it the way it is. So there's my new slope. M is going to be -2/3. The point I'm using is 6, 2. That's my new point. And then we just substitute it in. Here's x, here's y. We're going to solve and come up with a value for b. 2 is equal to -2/3 times 6 plus b. When I multiply -2/3 by 6, 3 goes into 6 twice, and I get -4 plus b, which means 6 is going to be my b value. So my new line equation is y is equal to -2/3 x plus 6. That line is going to be parallel to the original, and my original line is y equals -2/3 x plus 3. So now we're going to work a similar problem. I want to write the equation of the line perpendicular to 2y is equal to 5x plus 4, and this time passing through 10, -3. So what I want to achieve, I want to write the equation of a line. I'm going to write a line equation. And some important information is the fact that it's perpendicular this time to this line using this point. Perpendicular. Perpendicular means I'm going to take the slope and I'm going to find its negative reciprocal. So I'm going to start again with 2y is equal to 5x plus 4, and we're going to solve, and my original slope is 5/2. So here's my original slope. What I need is the perpendicular slope, which means I take the reciprocal and I change the sign. So 5/2 becomes -2/5. Now that I have that, I've got my slope, I've got my point. Here's x, here's y. We're going to substitute it into y equals mx plus b. Negative 3 is equal to negative 2 over 5 times 10 plus b. And the 5 reduces with the 10. Oh, I think that's what we got the last time, but it wasn't done on purpose. So negative 2 times 2 is negative 4 plus b. Now I have to add 4 to both sides, and I get a positive 1. So my final equation is y is equal to negative 2 over 5x plus 1. If you were to graph this and to graph the original, they would be perpendicular to each other. Perpendicular means they're at right angles from one to the other. So in class we'll practice more of this, looking at different examples and looking through a graphic organizer to kind of get everything pulled together.